The moon plays a crucial role in supporting life on Earth. To put its significance into perspective, consider that with no moon, human civilization as we experience it on Earth would be impossible. The absence of the moon would completely alter life on Earth. The moon's presence as a guardian and companion to Earth is a complete fluke of the cosmos. The moon has been around for nearly 4.5 billion years, making it one of the oldest objects in the universe with Earth. Nevertheless, it's far more than a gigantic rock hanging in the sky. Life on Earth would have catastrophic consequences if it were lost. The moon is crucial in maintaining Earth's orbit, making it habitable. Several ice ages have been attributed to minor tremors of the Earth's axis, which can have catastrophic consequences. Yet the motion would be far more catastrophic without the moon, which functions as a balancer, utilizing gravitational force to keep the Earth from migrating more alarmingly. Stay with us to the end of the video. There's a lot of information to be revealed. The moon's creation. While looking at the origins of the cosmos, quite a few different ideas have been proposed to explain how the moon came into being. According to one popular hypothesis, the moon could have originated from wreckage left behind after an asteroid. The mass of Mars crashed with our planet. The moon may have originated from matter already found in the planetary system's initial stages and eventually merge into a single structure. According to a second common notion, there is scientific proof that supports both of these hypotheses. However, it's currently unknown whether one is true. Despite this, the so-called colossal encounter idea has been the most widely accepted explanation. This theory proposes that the moon originated from a clash between primordial Earth and a rocky extraterrestrial planet, Theia. As of today, the specifics regarding how this took place still need to be clarified. There are also many more hypotheses for which researchers need help providing satisfactory justifications. In the course of the creation of the universe approximately 4.5 million years ago, it's assumed that the moon was formed. Regardless of whatever hypothesis you like to accept, this is the consensus among scientists. And it was precisely that occurrence that made it possible for the conditions on Earth to become just right for the development of life. If the moon were absent, the Earth's atmosphere would be altered. We could get precise quantities of the necessary gases in the correct environment. On the other hand, if the right proportion of gases hadn't been there, the evolution of life as we recognize it certainly would have never occurred on Earth. The Earth's actual tilt. It's been speculated that the absence of the moon, the Earth's actual tilt may shift upwards as much as 85 degrees, transforming all we know about meteorology into a heap of debris. However, this would be a direct situation. Whether on land or in the seas, the moon also has a real part of how it functions, and the gravitational pull it generates is the primary factor that determines the nature of its effect. Because the moon is far less massive than the Earth, and is located approximately 384,000 miles from us, the moon's gravity is not quite powerful enough to draw our planet towards this. Yet it does have the effect of stretching us all out. The moon exerts a slight gravitational force on whichever side of the Earth it's now confronting it, resulting in high and low tides. This tug is invisible to us, but responsible for tidal currents. Yet this phenomenon not only dictates how long we bask in the sun at seaside, but is also liable for developing particular habitats and various biological cycles within our organs. If the moon were to vanish, so would all the waves in most places. Although the gravitational pull of the sun is indeed liable for a whole proportion of the Earth's tidal force, there is still very little movement taking place. Of course, the planet we live on isn't the only thing that would be changed. The moon also strongly impacts human beings. Full moons can trigger seizures in people with a severe form of photosensitive epilepsy because of the increased brilliance in the sky. The no moon, Earth days and nights. A research study carried out in 2017 and reported in the BMJ discovered a 5.3% rise in the number of deadly motorbike accidents that occur when a full moon is observed. This is most likely because of the optical distractions and illusions that occur at this time. Many scientists agree that the best experience to go sightseeing is on the eve of a new moon, when the nights are at their deepest. However, other experts dispute assertions that a full moon may affect menstruation and sleeping duration. If you're fascinated by identifying constellations, your task will become much simpler if the moon abruptly and permanently departs from the sky. This is because it will be much easier to see the stars without the moon in the way. Nevertheless, although dark sky could be easier, you would have a different amount of time to appreciate it. This is because the absence of the moon would lead both days and nights to be far shorter than they are now. Whenever the Earth was first forming, a day lasted for fewer than 6 hours. Yet over the time that followed, the tidal friction caused by the pulling of the Earth and the seas slowed right down the Earth's rotation, causing it to slow down to a present rate of 24 hours a day. If the Moon abruptly stopped orbiting the Earth, there would be nothing left to act as a brake on our progress. Each day and night would progressively become shorter once more. The fallout of the ecosystems. The subsequent effect would be a total disruption of the ecological processes in the area. According to a research study that took place in 2013 and released in the Journal of Animal Ecology, species that depend exclusively on their eyesight as a primary sense, such as big cats, tigers, and eagles, depend primarily on the existence of the Moon because it generates contrast in the inky blackness, which allows them to chase and conceal effectively. If you remove the contrast, the hunters in particular would be at a massive disadvantage, resulting in the breakdown of regional food networks and maybe leading to an increase in the population of the victims. We could also expect a world full of rodents, mice, and other creepy crawlies securely wandering about, in addition to all of the tidal fluctuations and actual shunts that are currently occurring. In a world without a moon, aquatic life would be thrown into disarray for the same reason, which brings us full circle to the most glaring difference that would merge. The tides. Many marine fish type inhabit the region around high and low tides. These animals need continuous and assured water circulation for their existence. Without that, they would perish, and without them, the organic source of materials and nutrients that it delivers would be eliminated, leading to the collapse of even more food sources. When flying birds cannot find food, a primary food supply for creatures living on the ground is eliminated, and so on. As the day progresses, local climates will change without the moon becoming more severe. Once again, this would be mainly due to the decreasing tides as oceanic mobility factors tremendously toward shifting weather patterns throughout the Earth and controlling what kinds of weather hit particular regions at given times. Because our planet is composed of water for around 71% of its total area, our waters absorb the vast bulk of the ultraviolet radiation that reaches us. One way the oceans contribute to developing arid or humid regions is through evaporation. On the other hand, they operate as a universal mixer that spreads sunshine, sending hot water and precipitation from the equator down to the poles and resurrecting ice water to places closer to the equator. This cycle continues until the sun finally sets. In the absence of this mixing, the rays coming from the sun would be unevenly dispersed, leading to both intense and unexpected situations. Rise and dipped ice caps and gigantic flooding. Weather conditions would remain the same, and there would be no means of fleeing the bone-chilling cold and frigid lows in the polar regions, or the scorching and steamy highs that prevail around the equator. In a short amount of time, there could be widespread emigration worldwide, assuming that we're still alive. This allows us to return to the worst possible case and the more structural shifts it would undergo. Even without the moon, our Earth would initially experience a wobbling motion. Then over time, it would become gravitationally connected to other planets within the solar system, including Venus or Jupiter, which would cause it to lean in the path of those bodies. This would cause disruption, exceeding anything that a slowdown of the tides might entail when the Earth winds up amid a gigantic tug-of-war amongst its closest neighbors. From this vantage point, even without the moon approaching low levels with the actual tilt growing more and more erratic, Antarctica may discover itself confronting the sun, driven in that direction by certain fleeting body that is not the moon by any stretch of the imagination. Due to melting ice caps and extensive flooding, tropical forests would be forced to bleach out, and deserts could become the coldest regions on Earth. The events that would take place over centuries, and while it is quite likely that the planets themselves would endure, the fate of the human species would be unknown. Will we be able to effectively manage the global anarchy that would ensue if the moon suddenly vanished? Is the moon becoming farther away from Earth? Let's first investigate the factors contributing to the moon's receding orbit around the Earth. One of Newton's laws, the conservation of angular momentum, is what everything comes down to. The tidal forces are created when the moon's gravity exerts a pulling impact on the planet. These forces are responsible for the bulging of seas and slowing of Earth's rotation. A reduction in that rate at which the Earth rotates will in turn accelerate the moon's orbit, which should increase in size to maintain the same total momentum for the Earth-Moon system. The distance between the Moon and Earth is increasing at an average rate of approximately 1.49 inches annually. And as it does so, its orbital period lengthens, which in turn causes the Earth's rotation to become slower. Considering the average pace of retreat during the past 4 billion years, it's estimated that it will be another 50 billion years before the Moon's orbit around the Earth occupies the same amount of time as one revolution of the Earth. When this occurs, Earth will be in a state known as tidal locking. The moon will permanently be positioned directly above in the same place on the planet's surface. More than half of the Earth's population will never see the moon. The fluctuating influence that the moon has on our waves would also come to a stop, while the sun would still cause some tides depending on the passage of time. The tidal conflict between the sun and Earth would ultimately reverse the process by which the Earth and moon form their relationship. This would draw the moon increasingly nearer to the Earth until our planet's gravity ultimately tore apart the moon. After 50 billion years, the sun will undoubtedly have already transitioned into a white dwarf. This is something that will take place 10 billion years from now. In addition, it's a high probability that both Earth and moon will perish due to the sun entering its sunset years. Thanks for watching. If you have any questions, let us know in the comments section. Also, at last, give a like to this video. See you soon.